But my name's Josh, and today I'm going to be looking at attentional distribution in the processing of speech. So both articles I'm discussing today deal with speech, and there is some important background information I'd like to share that cover both papers. So first, the processing of speech depends on the rapid encoding and interpretation of complex audio-visual signals. This makes it a seemingly difficult process, but language also contains some structure to help us. So it contains phonetic structure, lexical structure, syntactic structure, semantic structure, and prior knowledge of these helps facilitate our processing of it. So while someone talks to us, we may selectively shift our attention between different parts of the face, and it has been shown that typical gaze behaviour will change as age increases. So these changes in gaze behaviour with age can be used to compare typical and atypical language development. So this is the timeline that collates the previous findings discussed, particularly from the first article that I'll get to. And these are important, and the findings have some key implications for this timeline, which this will portray a typical development of an infant. So from 0 months to 12 months, so this is the first year of a child's life. So in the yellow here, we have some previous findings illustrating what infants prefer to focus on when exposed to a talking face. Newborns prefer to focus on the eyes, and then between 3 and 11 weeks, they focus on eyes 10 times more often than they do on the face's mouth. And then at 6 months, there's an increase in looking time at the mouth, but it still doesn't surpass the amount of time they spend looking at the eyes. But there's thought in this period here, between 6 months and 12 months, to be a period where they shift to look more to the mouth than they do at the eyes. But this needs more studying, which is where my first article will come in. And then finally, endogenous attention develops in this period after 6 months, which is the infant's ability to internally control the attention they direct to the external environment. And now in red, there are key stages of language development. Between 3 and 5 months here, infants will start to imitate simple vowel sounds. At 6 months, canonical babbling begins, and this is the repetition of vowel or consonant sounds, such as ba, ba, bo, bo, mama, that kind of thing. And this happens at a similar time as the increase in looking time at the mouth at 6 months. And then canonical babbling starts to reflect the infant's environment from 8 to 10 months, and we'll see this come to play later on. Furthermore, the infant is said to gain a level of expertise in their native language at 12 months, and with it comes a narrowed sensitivity to additional languages. In addition to this, at birth, babies can perceive low-level audio-visual relations based on intensity and synchrony. They gain more sophisticated multi-sensory integration abilities with increasing age, such as the ability to detect temporal coherence, associate faces and voices, and a key ability in today's articles, which is to match and integrate auditory and visual attributes of speech. And the emergence of these multi-sensory perceptual ability depends on early experience with coordinated audio-visual inputs. So why might a shift towards the mouth occur, and what would happen if early multi-sensory experiences do not occur? So firstly, McGurk and MacDonald described linguistic communication to be multi-sensory, as we typically see and hear someone talking, and not just hear someone talking or see someone talking, and then we automatically integrate these signals. Successful integration, though, requires a perceptually more salient signal, according to Rowe, 1999, who found that concurrent access to redundant audible and visible speech cues enhance speech perception under noisy conditions. And by redundant, I just mean additional cues that aren't necessarily vital to the understanding, but can definitely aid the perception of it. So when an auditory signal is poor, such as being in an unfamiliar language or in a noisy condition, access to the mouth is actually beneficial to still be able to understand the speech. The advantages of infants focusing on the mouth include facilitating imitation, allowing benefit from increased salience, provided by multisensory redundancy and increases in motivation to talk. But I'll return to these functions later on in the discussion. There is another finding that suggests that shifting attention to the mouth is essential for development. So Younger Town 2009 found that infants who look more at their mother's mouths at 6 months will score higher at 24 months in such things as expressive language, size of vocabulary, and socialization measures. The eyes are also important, so as well as the mouth, the eyes are also important to focus on as they provide important social and didactic cues which are important for further cognitive development. Didactic cues just being cues that are context dependent. And then finally, the first article, which is coming up now, highlights some research that found deficits in later childhood when infants are deprived of early multisensory experiences. So it was found that deprivation in early visual input led to neural and behavioural deficits in multisensory integration, and furthermore, children with autism spectrum disorder often exhibit audio-visual speech integration deficits, and this is thought to be because patients with children with autism spectrum disorder tend to pay less attention to their faces during development. So this brings me on to the first article by Lukowitz and Hansen-Tift called "Infants Deploy Selective Attention to the Mouth of a Talking Face When Learning Speech." So the purpose of this study was to track gaze behaviour in 4 to 12-month-old infants and in adults in response to someone speaking in a native or non-native language. The researchers predicted that infants would decrease their looking time at the mouth at 12 months of age, which is when expertise in native language increases. This prediction, therefore, is only made for infants in response to native language speaker and not the non-native speaker. For the non-native, for the speaker of the infant's non-native language, it is hypothesized that the infant will continue to focus on the mouth to take advantage of the audio-visual redundancy cues, which can benefit from the when the auditory stimuli is disrupted in some way, as I said earlier, maybe when it's an unfamiliar language, as here, so it would be the non-native language. So experiment 1 used separate groups of 4, 6, 8, 10 and 12-month-old infants as well as adults. So they had 89 infants in total and 21 adults with an even distribution between groups and also an even split between male and female. They then watched a 50-second video of a female actor talking in their native language of English. They varied prosody, which means that the same monologue was recited in either an infant-directed manner or an adult-directed manner. An adult-directed manner is just typical adult speech, whereas the infant-directed manner is slower, more exaggerated, with continuous smiling, the kind that would attract an infant's attention. Oops. They then tracked the participants' point of gaze with 2 defined areas of interest, the mouth and the eyes, and they generated a proportion of total looking time, or PTLT, by dividing the total amount of looking directed at each area of interest divided by the total amount of looking at the rest of the face. So these are the proportion of total looking time scores it generated. So you can see the shift from focusing on the eyes more at 4 months to then start focusing more on the mouth down here. So this is just the difference between, so here they focus more on the eyes than the mouth, and then this will be focusing on the mouth more than the eyes. Between 4 and 8 months, infants decrease looking time from the eyes, so between here and here, while increasing looking time on the mouth. And then between 10 and 12 months, infants decrease looking time at the mouth while increasing looking time at the eyes. This is consistent with the prediction that the emergence of native language expertise reduces the need for direct access to redundant audio-visual speech. Experiment 2 was using an identical procedure to experiment 1 with 90 infants and 19 adults. But this time the female actor spoke in her native language of Spanish, which was a non-native language an unfamiliar language to the participants. And this is what they found. So if you remember, it was expected that attention will remain on the mouth, as this is a visual cue that can help integrate speech when audio information is unfamiliar. So here, researchers replicated the finding of the first shift shown in experiment 1 of the infant shifting their looking from the eyes to the mouth between 4 and 8 months of age. This time, the looking time of the eyes decreased and looking time at the mouth increased. So that's the same as experiment 1, but now at 12 months, you see that the infants took longer looking at the mouth, which is so they looked at the mouth 42% of the total looking time, which is much larger than the time they spent looking at the eyes, which was 12%. Researchers also did some additional analysis where they looked at pupil dilation. And pupil dilation is an indicator of a person's state of arousal in response to visual and auditory stimulation. So they hypothesized that infants might exhibit greater pupil dilation in response to non-native audio-visual speech, but not to native speech. When they performed this analysis, they found no difference in pupil size in response to the English monologue, but they did find an increase in pupil size as a function of age in response to the Spanish monologue. So you can see this here. So this is in response to the Spanish monologue. So interestingly, the increase in pupil size occurred at 8 months and remained at that level up until 12 months. This increase corresponds with the initial attentional shift to the mouth found in experiment 1 and suggests that infants were reacting to the novel attributes of what is now unfamiliar speech. The expertise increases in the second half of the first year of life, so between 6 and 12 months, and with it perceptual narrowing occurs, and it is likely then that this pupil size data reflects the narrowing which renders the Spanish monologue to be a novel stimuli, which it wasn't before. So here is a new timeline created from the findings of Lukowitz and Hansen-Tift. So they found that 4-month-old infants show greater looking time at eyes, and then 6-month-olds, there is an equal time spent looking at the mouth and the eyes, but then at 8 months there's a shift to the mouth regardless of language, but then it's at 12 months where you see the difference. So native language elicits a response in the infants where they shift attention away from the mouth, but then the non-native continue to focus on the mouth because the speech is unfamiliar. So what is the significance of the timing of these attentional shifts? There are 4 reasons the authors propose for this. So firstly, it is advantageous in terms of imitation. So the period after 6 months is when the infant's babbles start to reflect the environment. So imitation is definitely taking place here. But being able to focus on the mouth is useful. So the infant can actually start to reproduce speech-like sounds and develop their speech from sounds to actually things that sound more like words. And this happens through imitation. And access to the mouth is important in making the redundant audio-visual speech cues available. So I said before that they were advantageous in understanding language. Being able to access the mouth allows the infant to benefit from the salience of this multisensory information. There's also an increase in the motivation to talk, which may lead to directing attention towards the source of the audiovisual speech, which is, of course, the mouth, which the infant then wishes to replicate. So this ties into the first reason. And then also endogenous attention develops after 6 months, which permits the infant to direct their attention towards the mouth and facilitate all of these occurrences. The authors also make some speculations on how an atypical development might look like in infants at risk for autism spectrum disorder. So it has been found previously that 1-year-old infants at risk for ASD look more at faces, and that 2-year-old infants at risk for ASD look more at the mouth. So it's clear that this is a different developmental path than as I showed you earlier. So the author proposed this as a likely path for infants at risk at ASD. So at 4 months, there is a greater looking time at the eyes as normal, and by 8 months there is the same shift towards the mouth that would have occurred. But then there was a failure to shift attention back to the eyes, even for native speech. And this could be because of the infants being too captivated by the greater audio-visual stimulation coming from the face, but also the failure to perceive multisensory coherence of the audio-visual speech, as demonstrated by older kids with ASD. So as a result of this, the infants at risk for ASD are unable to extract communicative meaning. So there's no development of perceptual expertise for native speech, which would allow shifting of attention to the eyes to access the social cues that are important for their cognitive development. So the authors thus suggest that the findings from the findings that gaze behaviour could be used as a diagnostic tool, where looking at the mouth beyond 12 months of age could be an indicator of ASD, but more research is definitely needed here. They didn't actually provide any findings on infants with ASD. This is just their speculation from looking at the timeline of normal development. So, as I said, more research is definitely needed to back the speculative claims about the autism spectrum disorder. But the actual experimentation was really well performed with an impressive number of infants. It's difficult to get the number of infants they did. They had between 15 and 20 in each group for both experiments. And I think they had 79 who they had to take out of the experiment due to lack of cooperation. To get the volume they did is impressive. It is debatable, however, whether the trials are representative of real-life social interactions. So would attention differ between watching an unknown person on the screen speak, as they did in this experiment, compared to the mother speaking to the infant? But despite this, the effects are still quite clear, with significant evidence for the shifts that they claim to occur. There is, however, a lack of explanation for why no difference was found between eyes and mouth at 6 months. This is assumed to be part of a gradual shift towards the mouth, but it's unknown whether this shift has already started in some infants and it hasn't in others, and it averages out for there to be no difference between eyes and mouth, or whether all of them are shifting at a similar time, but the individual data isn't available to examine this further. One other issue is that just monolingual English participants were used, which reduces the scope of the findings to apply it to other languages. But it also fails to rule out, because of this, it fails to rule out the influence that innate properties of the English language could have in affecting the distribution of attention. So going to my second study now, by Baron, Holtz, Mavica and Lukovic, 2016, called Language Familiarity Modulates Relative Attention to the Eyes and Mouth of a Talker. So I've covered most of the backgrounds, but there's just a couple more things I'd like to highlight. So first, familiarity is a key factor in language perception. So Cutler et al. In 2004 found the perception of auditory speech to be more accurate under noisy conditions when the spoken language is familiar. And the authors suggested that consequently it can reduce bottom-up processing required for successful interpretation of auditory speech. The question, though, is whether language familiarity also affects the response of audio-visual speech, so the combination of hearing and seeing speech, which obviously has multisensory information. Secondly, the type of task has been shown to mediate attention distribution, so the mouth attracts more attention when the speech is relevant. So when the task is to focus on social or emotional cues, the eyes attract more attention, but when the participants are actively engaging in the speech, as you'll see in this experiment, they actually focus on the mouth. So this is actually a mediator which wasn't considered by the authors of the previous paper. So the research question posed in this paper takes into account all of these previous findings and clearly defines their context. And their research question is, does familiar language cause adults to attend more to a talker's mouth when the explicit task is to process the speech? So even though the first study, Lukovic and Hansen-Tift, found greater attention towards the eyes for adults in both language conditions, it was actually a passive task. So they were just the participants were just seated there watching the video, whereas here it is expected that a task which explicitly demands attention will lead to a different attentional response. So the researchers predicted that participants will attend more to the mouth in the unfamiliar language condition. So 3 experiments were conducted. So here in experiment 1, 2 video segments were presented, followed by 2 audio-only segments. And then the participants then had to say which audio clip matched which audio-visual clip, which is obviously demanding the explicit attention. 3 areas of interest were defined, which were the face, the mouth, and the eyes. And then fixation time for the eyes and mouth were calculated as a percentage of the total face area. So the first experiment, there were 2 groups of 30 in either an English and Icelandic condition or an English and Spanish condition. And then these were subdivided into further groups of 15 so that participants were exposed to a native language first or a non-native language first. So either the English or Icelandic or the English and the Spanish. So what did they find in experiment 1? So these graphs show the proportion of time fixation of time fixating the mouth and eye regions for the English Icelandic group on the left and the English Spanish group on the right. So they found greater overall fixation on the mouth than on the eyes, and this is consistent with previous evidence that finds greater fixation of the mouth during active speech processing tasks, and obviously differs from the previous study who showed greater fixation of the eyes in adulthood. But they of course used a passive task, as I said. So in line with the hypothesis, they found participants looked more at the mouth when the speech was unfamiliar compared to when it was familiar. So a paired samples t-test found that the mouth versus eyes difference was greater for the Icelandic block of trials compared to the English block of trials over here, and then the same again here where there was a greater difference between mouth and eyes in the Spanish condition compared to the English condition. So like in the first article, experiment 1 used only monolingual English speakers as participants, which is a limitation, and it aims to compare fixation during familiar and unfamiliar language encoding, but it is possible that some property of the English stimuli cause lower amounts of attention directed to the speaker's mouths, rather than the familiarity causing this effect. So to test this, the current researchers used the same task but with 30 Spanish-English bilingual participants, and if it is the familiarity that modulates attention, then these bilingual participants should exhibit an equal amount of attention to the talker's mouth for both languages. And these are the results, and indeed they found no significant differences between the English block of trials or the Spanish block of trials in terms of the mouth versus eye differences. So there's a similar difference between the mouth and the eyes for both English and Spanish. I should say also that the matching task scores were near ceiling, so they're between 95 and 97% for all trials. So participants were basically successful at matching the subsequent audio clips to the audio-visual clips in the lead-up to it, regardless of the language or the language expertise. Language expertise just meaning whether they're bilingual or monolingual. They also compared the scores of the monolingual and bilingual participants between experiment 1 and 2 because they had identical procedure. So in a two-way mixed ANOVA, they found a significant effect of language for English versus Spanish. They found a significant effect of language expertise, as well as a significant interaction. So this basically supports the hypothesis that familiarity is the determining factor and not language expertise, or the language use, I should say. So as mentioned before, the authors state that the reason the first paper found greater fixation on the eyes was because they only passively tested speech encoding. So the current authors' active processing hypothesis argues that an explicit information processing task will lead to greater looking time at the mouth. So to test if active processing mediates the greater attention to the mouth found in experiment 1, they tested a new cohort of 30 English monolingual participants. And they used a procedure identical to experiment 1, except there was no auditory task that followed the audio-visual clips, which was the manipulation to require explicit speech processing. And then they used the same block of trials they did for the English-Icelandic group. So the analysis found no significant difference between mouth versus eye look-in time for English and Icelandic blocks of trials. So when participants were not required to actively monitor the speech, there was no increased selective attention towards the mouth in response to the familiar language condition. Interestingly, there was still more look-in times toward the mouth, unlike in the first paper. So this could be due to the nature of the stimuli. So the stimuli were brief in this study, so they were 2.5 seconds, as opposed to the 50 seconds monologues used in the first study. And the isolated sentences were pronounced in a monotone manner, whereas the first paper used very prosodic manner. So like in the infant-directed speech, they used high prosody. So this could have led to greater emotion or the drift of attention during this much longer monologue of 50 seconds. The finding that adults devote greater attention to the mouth for unfamiliar language compared to familiar language supports previous findings that suggest adults seek out audio-visual redundancy cues when facing uncertainty over the auditory signal. So from this, it is clear that we possess a flexible system to modulate attention, which is likely based on the discriminability of the speech signal, speech processing demands, and individuals' perceptual or cognitive expertise. So compiling this evidence from the first article, it is likely that this system develops very early on in life and works in the same way as it does in adults as it does in infants. So this study also shows that the mouth is an important source of information during speech encoding, but it's not essential for integrating auditory and visual information. So the authors suggest that directing attention to the talker's mouth is a perceptual enhancement strategy, which is useful under suboptimal encoding conditions. So by this account, enhancement will be because of a high resolution of the mouth, which comes with greater fixation. Alternatively, the enhancement could come from additional processing that is required because of the increased time fixating the mouth. And this would suggest that the enhancement is primarily attentional in nature. But it is also possible that both factors contribute in combination. But more research is needed to be able to disentangle these two factors of attention or perception. So while the results are not necessarily groundbreaking in terms of they're not surprising, the study builds on some important findings to demonstrate that familiarity modulates the distribution of attention. What is good about this study is the well-defined context they test processing, in which they test speech processing, so it's not left to guesswork to figure out the effect of familiarity, but instead they make it very clear what the scope of the familiarity effect is. So here they showed that familiarity to modulate attention in monolingual adults and in tasks that actively require speech processing, which rule out other variables such as the innate properties of the English language. It improved on the first study in that they used bilingual actors who spoke both languages rather than separate actors in the first study to speak the different languages, which could, of course, have elicited differences in response. So overall, both studies contribute some fascinating findings on both the effects of familiarity and selective attention and the development of this attentional mechanism in the first year of life, highlighting the importance of the mouth in audio-visual speech processing. So thank you for listening, and happy to take any questions.
Out of curiosity,
Yeah.
for the first one, I believe they were looking at pupils and like how they were dilating when they looked at different things. How did they measure that? Because I feel like that's like, it can be so like your pupils are so sensitive to light and darkness. So how did they know that?
So they did control. So they used eye tracker devices to film the pupil, and then they measured the dilation of the pupils with that. But then the luminance was the same in both conditions. So they filmed the Spanish speaker and the English speaker in exactly the same lighting conditions, and then the infants were placed the same amount of distance away from the computer screen, so it should have been completely identical. It may have been, it was different people, but it should have been like negligible differences.
So I feel like one of the critiques was like using monolingual English speakers.
Yeah.
Because like they would like maybe some part of English might be focusing more on the mouth compared to the other languages. Like what parts of like the English language do you think might be causing that?
It's a good question. Maybe things to do with the pronunciation, so the way maybe a particular word is more interesting in terms of mouth movements than another language. Hard to say, it's just a guess, but that kind of thing could have an influence where it wouldn't do in another language. But you obviously wouldn't want to assume that all other languages are the same as English, because there's definitely differences there.
Yeah.
Prosodic factors definitely play a role in getting infants' attention.
Definitely.
Indicates novel information versus old information. So they really highlight novel information by pronouncing it with a higher tone or pitch. So that but all languages have prosodic factors, but it might vary. Like there are definitely different prosodic factors across languages. So,
but it's hard to control for that effect in infants because of just trying to get them to pay attention. So the high prosody is actually needed to attract their attention in the first place. So it's actually really hard to study this because of that.
So like kind of how the sound system, the symptoms, like if the languages go together, would be kind of how they would change their attention.
Yeah.
Like, what's that? Like how about like how like words kind of come together? Like, is that like phonology, like blending words together and figuring out that? No, it's not the right word. But like wouldn't that kind of like how like just kind of like never mind. I'm kind of thinking of something else. Sorry.
I wonder a little bit about gender differences. Like we know children, females usually start speaking their first words before males on average. Nothing like that.
They didn't compare any gender differences.
Because the males you think would be delayed in the shift.
Yeah.
On average.
Yeah, that wasn't mentioned in any of the articles.
Great, thanks. That's good.
Thank you.